Alrighty, let's get her going on 4.5. We're now going to be looking at equivalent forms of our quadratic functions. So we're going to be taking it from our one form into the other form. The two forms we've looked at so far are y equals ax squared plus bx plus c and y equals a bracket x minus p squared plus q. Let's start by factoring each of these trinomials. All right, we've got our sum equals -10. Our product equals 25. The two numbers that are going to give us those are, look at that, -5 and -5. Oh, they're both the same. So we've got x minus 5 and x minus 5, which means x minus 5 squared. And now it says, how is the third term related to the second term? So we're reminding ourselves of how these perfect square trinomials are put together. So our 25, hey, that's 5 squared. And our 10 here is 2 times 5. Let's go to the second one. We've got a sum of 18, a product of 81. Oh, look at that again. We've got 9 and 9, both the same. So x plus 9 and x plus 9. Or in other words, x plus 9 squared. Let's look at those again and see if they are related. The 9 squared. 18, 2 times 9 works the same. So these again are perfect square trinomials. And we dealt with those in chapter 3. Okay, looking at the two different forms we have. First column being the vertex form, second column being the standard form. All right, so we got to match them up. Well, there's a number of different ways of doing this. One way is to take your vertex form and just expand it. So y equals -x minus 2 squared plus 7, and start expanding it. X minus 2 times x minus 2 plus 7, and distribute that out. Or remembering the rule, it's going to give us -x squared minus 2 times, so 4x, and then squaring plus 4. And then distribute in that negative. And combine your last two terms there together. And we can see that one right there is this one. And you could go through, you could do that to all of them. You could graph the two of them, see which ones turn out to be the same graphs all the way through. So lots of different methods in this kind of a process to match up the graphs. So we're going to be transferring from the standard form into the vertex form. Another name for the vertex form is the completed square form, because we're going to get to that form by completing the square. Before we look at doing it algebraically, we're going to look at how the algebra tiles work so you understand the process. And again, to warn you for the volume here, we got the lady would love to talk to you about it.
Consider the quadratic function y equals x squared plus 6x plus 1. We can use algebra tiles to model the process of completing the square. These tiles model x squared plus 6x plus 1. We can arrange the tiles to try to form a square. To complete the square, we need to add 8 1 tiles. We don't want to change the value of the expression, so we add 8 0 pairs. The tiles model x squared plus 6x plus 9 minus 8, which is still equal to x squared plus 6x plus 1. The square has side length x plus 3, so x squared plus 6x plus 9 equals x plus 3 squared. and the tiles model the expression x plus 3 squared minus 8. So, the equations y equals x squared plus 6x plus 1 and y equals x plus 3 squared minus 8 are equivalent.
Okay, so going through the example that they have there in your book, y equals x squared minus 4x plus 10. Let's complete the square on the right side. Notice that this is going to be slightly different than the process we used for completing the square for equations in chapter 3. Here we're going to keep everything on the right side because we don't have 0 on the left side, we've got y there. So step number 1 is going to be bracket off the first two terms, the terms with the x. Bracket them off. Then our second step is going to be we've got to add something in, and instead of adding it to the other side as well, we add it in and we subtract it away. Put it in, take it away. What is that something? It's the same process we did before. Divide by 2 or take 1/2 and then square it of the middle term. The next thing we have to do is to kick out that negative. So this -4, we're going to kick it out of the brackets. The only way we can do that is by multiplying it, whatever's in front. And this just happens to be a 1, so it makes it easier to kick that and multiply, distribute that in. And then combine your last two terms together. We now have them in the completed square in the vertex form. They are both equivalent forms. All right, let me walk you through a little bit more of a difficult one. So remember that our goal is to get into y equals a bracket x minus p squared plus q. Notice that the a is out in front. So step number 1, bracket off your first two terms. Now, step number 2 is going to be bring out the leading coefficient. Whether or not it nicely divides, we have to take out the a value of the brackets. So 3 bracket x squared minus, now it's not 12 any longer, it's 4x plus something, and I'm putting it in, and I'm going to take it right back away. I don't put it on the other side of the equation. I'm going to put it in, take it away right inside those brackets, plus 7. Now what's that something again that we're going to put in and take away? Well, we're going to take our -4, divide it by 2, always divide it by 2, and square it. Same reason as what we did in chapter 3. -4 divided by 2, -2 squared gives me 4. 4 goes in, 4 goes out. Now we got to get that -4 out of the brackets. Only way we can do that is to distribute in the 3 to that -4. Keep the 3 in front for the other parts. 3 bracket x squared minus 4x plus 4. But now I've got minus 12 plus 7. And that minus 12 came by 3 times the 4. I can combine my terms on the end. -12 plus 3, plus 7. That gives me -5. And the last thing, I'm going to factor what's inside those brackets. But I know what it's going to factor to. I made it. I made a perfect square trinomial there. So x minus, right before you squared it. That's what's going in here. Same sign as what's above, -2 squared minus 5. We now have it in completed square form, vertex form. Determine the coordinates of the vertex. That's really the whole purpose of being able to do this, is algebraically getting the vertex. So the vertex is our P, comma Q. Additive inverse of P, 2, comma, -5. There's your vertex. Now, just to remind you, What happens if we have a negative leading coefficient? If that's a is negative, again, we're going to follow the same process, but just be careful. We're going to bracket off the first two. It's always going to be your first step. Factor out the negative 1 out of the brackets. Leave that negative 5 untouched. Just leave it there. And then don't forget that if you're factoring out a negative, here's where the problems arise. This is where people make the mistakes. It was positive. We pulled out a negative. And then we do the same thing. Take the negative 12, divide by 2, square it, and we run it through exactly the same. Let's do another example where that's going to be an issue. All right, step number 1, bracket off the first two terms. Step number 2, factor out the leading coefficient. Whether or not it's a GCF, doesn't matter. You have to factor out the negative 2. X squared, I pulled out a negative. Do not forget, this is where the first of a few issues can arise. If you can pass these two main problems, you're probably going to get it right. Factor out the negative 2, leaves you with negative 5 over 2x. Plus something, minus 3. Let's figure out that something. We're doing negative 5 over 2 divided by 2. That's the same as multiplying by 1/2 and then squared. That gives me negative 5 over 4 squared. Squaring the 5 gives me 25. Squaring the 4 gives me 16. 25 over 16, that's the number I'm going to use. Throw her in there. And take it out. Put it in, take it out. But now we've got to kick out this last term. This one can't stay in there. So I'm going to take the negative 2 and multiply it to the negative 1. We always kick out the negative 1. It's too negative to be staying in there. Let's get it out of there. Negative 2, bracket x squared minus 5 over 2x plus 25 over 16. 25 over 16. We're going multiplied by the negative 2. That's going to make it positive. That's like 2 over 1. I'll just write it on the side here. We're multiplying it by the 2 over 1. Hey, divide first. That's going to leave me with 8 there. So we've got 25 over 8 minus 3. Oh, I need to change that. I need a common denominator of 8. That's the same thing as saying 24 over 8. So I'll change that to 24 over 8. Now I'll be able to combine those together. So then y equals negative 2 bracket x squared minus 5 over 2x plus 25 over 16. Adding them leaves me with positive 1/8. Last thing I'm going to do is factor inside the brackets here. Y equals negative 2. I know that's a perfect square trinomial that I made. It's going to be x, same sign, minus. Right before you squared it is what's coming in there. Minus 5 over 4 bracket squared plus 1/8. Done deal. We've got the vertex form. We've got completed square form. I can figure out, ooh, this time I want to know the axes of symmetry. Perfect. It's right here. X minus 5 over 4 equals 0. X equals 5 over 4. Done. All right, last example for you. We're looking for the y-coordinate of the vertex. In other words, the maximum or minimum. Well, let's decide. Is it a maximum or is it a minimum? Well, my a value is positive. That means it has to open up to the positives. So therefore, that vertex has to be a minimum. So this question could have been asked, what's the minimum value? Well, let's do it. Oh, they got fractions in there. Ah, they're trying to make it tough on you. No big deal. You can handle it. 1/5 x squared plus 2x minus 1. Step number 1. Same steps as always. Bracket off the first two. We need to factor out that leading coefficient. Whether it nicely comes out or not doesn't matter. Got to pull it out. Y equals 1/5 bracket x squared plus, 2 divided by 1/5. Let's write that on the side. What the heck is that? Oh, dividing by 1/5 is the same as multiplying by the reciprocal 5/1. That's 10. 10x plus something minus 1. Got to figure out the something again. Take that middle term, 10, divided by 2, and squared. So we get 5 squared, 25. 25 is going in, 25 is coming right back out. Keep it all value the same. But I can't leave that -1 inside the brackets. It's too negative inside the house there. Getting kicked out. Multiplied by the 1/5. So y equals 1/5 bracket x squared plus 10x plus 25 minus 1/5 of 25. That's 5 minus 1. Hey, you know what? We can start combining things together. You can start skipping some steps. We know that it's going to combine together. X squared plus 10x plus 25. You made it. It's x plus whatever's right before you squared it. Same sign. Plus 5 squared. Minus 5 minus 1, minus 6. There's your completed square form. But we want to know, what's the y coordinate? What's the minimum value? Oh, that's sitting right here, right on the end. So y coordinate of vertex equals -6, or minimum value equals -6. Now, just to remind you, we can always go back the other direction. If we've got completed square form, all we've got to do is we can distribute it, we can expand it, or we can use our graphing calculator just to check to make sure that the original and what we came up with are the same forms. Ooh, you've got to be able to identify quadratic functions in this course. So why is this a quadratic function? And what's the advantage of taking it into the vertex form? Why would we want to complete the square? What's the point? Answer those two up, and we'll see you in class.